Okay, S is a set that contains all positive integers less than 81 that are not squares of an integer. So what are squares of an integer? So squares of an integer are, so 1 squared is 1, right? So 1 is an integer, and integer squared is 1. And 2 squared is 4. 3 squared is 9. 4 squared is 16. 5 squared is 25. 6 squared is 36. 7 squared is 49. 8 squared is 64. And 9 squared is 81. So 1, 4, 9, 16, 25, 36, 49, 64, and 81 are squares of an integer. So set S is a set that contains all positive integers less than 80. So that contains all positive integers. So it starts from 1 all the way up to 80. So not including 81. Okay? But it includes numbers that are not squares of integers. So it shouldn't include 1, 4, 9, 16, 25, 36, and 49, and 64. Of course, 81 is out of it because it must be less than 81. So, if this condition that are not squares of an integer, if this didn't exist, okay, then the answer would have been just 80. How many numbers are there between 1 and 80? That's 80 minus 1, which is 79, plus 1, so that's 80. So the answer would have been 80 for the number of elements in set S. However, how many squares of an integer are there between 1 and 80? So that's 1, 2, 3, 4, 5, 6, 7, 8. So the set doesn't contain those. So 1 is out, actually. So this is actually not the set S. So it's not there. 1 is not there, and 2 is there. 3 is there. 4 is not there. 5 is there. 6 there. 7 there. 8 there. But 9 is not there. And 10 there. 11, 12, 13, 14, 15, and 16 is not there, 17 is there, etc., etc. It goes all the way up to 80. Okay, so it would have been 80 terms, 80 elements inside of it. But then you have to subtract 1, 2, 3, 4, 5, 6, 7, 8 of them. So it's 80 minus 8, so that's equal to 72. So the number of elements, the number of items in set S is 72. That's 80 minus 8. And the quantity A is 73, so the answer is A. So quantity A is greater.